The derivative of tangent is secant squared of x, and derivative of cotangent of x is minus cosecant squared of x. And derivative of secant of x is secant of x tangent of x. And derivative of cosecant of x is minus cosecant of x times cotangent of x. Those are the essential derivative formula you have to remember all the time. Some of the problems next week in the quiz will be related to the derivative and antiderivative formula. So you have to go through and make sure you remember everything correctly. We have integration 9x squared minus 9 times secant squared of x cubed minus 3x dx. This is a product function, so we can consider substitution, and we have to identify which one is which. This function is a secant function, secant squared function, but inner function is a little bit more complicated. And this part has one less degree. So if you put u here, and if you differentiate it, then you will have 3x squared minus 3. So we can consider this one as 3, open parenthesis, 3x squared minus 3. And then that can be regarded as 3 times du, right? Let me write that down. We put u equals x cubed minus 3x, and dx equals 3x squared minus 3, and then dx. So given integration can be rewritten as integration secant squared of u, and these two are combined, and I will write 3 times du. So that'll be rewritten as 3 integration secant squared of u du, and then that is 3 times tangent of u plus c, because derivative of tangent is secant squared. The original variable was x, so we will replace u by x cubed minus 3x. So 3 times tangent of x cubed minus 3x plus c. Any question? The next one is integration 40x cubed times secant 7th power 2x to the 4th power times tangent of 2x to the 4th power dx. There are 3 functions multiplied together. It's quite complex. If we think about derivative of tangent, then it will result in secant squared. And if you break secant 7th power to secant squared and secant to the 5th power, then we will have problem because we cannot deal with secant to the 5th power. But if we think about secant function primarily, and then if we think about the derivative, then we have secant and tangent. So we get an idea that we break secant to the 7th power into secant times secant to the 6th power, right? So this can be rewritten as secant times secant of 2x to the 4th power times secant to the 6th power 2x to the 4th power. Then what we can think about is this is secant to the 6th power. Maybe I would put secant as u. Then secant tangent, each combined one will be the derivative of secant. But we know that we're trying to set secant of 2x to the 4th power as u. Then what will happen will be that itself is a chain, the composite function. So to differentiate, we have to apply the chain rule. And inner functions derivative related factor appears here. So that is the right strategy. Let me tell you this again. So our strategy will be, we will put u equals secant of 2x to the 4th power. Then du will be secant tangent, secant 2x to the 4th power times tangent 2x to the 4th power, and that's a chain rule. So we have to differentiate the inner function again. Then that is 2 times 4x cubed. Dx. So that becomes du equals 8 times x cubed secant of 2x to the 4th power times tangent of 2x to the 4th power dx. So, what can we do with this? We rewrite this like this. So integration, we put u equals secant of 2x to the fourth power. And we will think about u to the sixth power. So I would write secant to the sixth power times secant of 2x to the fourth power times tangent of 2x to the fourth power times we can rewrite this part as 5 times a times x cubed dx. Any questions so far? So what we want to think about is this part will be u to the sixth power. And I said secant, tangent, and 8x cubed. So this part all together will be du. And this 5 is a number, so I will write it in front of integration. So we have 5 integration u to the sixth power du. And then that is 5 times u to the seventh power over 7 plus c. And then that is 5 over 7. U was secant. So secant to the seventh power 2x to the fourth power plus c. Any question? Yeah.
Just make sure I understand where that five's coming from. Is that from the derivative of the secant to the power of 6? The u6 is the power of 6 from?
It comes from here. Is that your question?
Yeah, I just want to make sure.
Yeah. Yeah, because u is secant. Yeah.
The third power and then the 4 atoms and out of 3. And we get 5 stuff.
So all I was saying was 40 is 5 times 8x cubed, right? In the original problem. And 8x cubed is coming from one of the factor in du.
You're not lost by the square.
No, I just copied the original one down, right? So I just organize it differently. Yeah. And so instead of 40, I would write 5 times 8. So the starting point and this point are just the same with different expression. Do you have any other question? This is not an easy problem. Is it clarified or what?
Yes.
The 1.6 is about integrals. Involving exponential and logarithmic functions. Just a moment. Let me remind you the antiderivative formula for the exponential function. That is the exponential function itself if the base number is e, and if we integrate 1 over x, then that is natural log of absolute value of x plus c. If we have the log base b and integrate, then that is b to the x over natural log of absolute value of b plus c. And if we have integration of natural log of x dx, then that is x times natural log of absolute value of x, or just I think we have to write absolute value of minus x plus c. Again, all of them are essential formula you have to remember. We want to do indefinite integral 3 times e to the 2 over x cubed over x to the 4th power dx. This is a fraction function, and we can regard a over b equals a times 1 over b. So that's a product function. And we want to consider the substitution method because of that. In this case, we have to compare the numerator and denominator and think about which one is the derivative of what. Obviously, if we differentiate this one, then we will have 1 over x to the 4th power as one of the factor after the differentiation. So we will decide to place u equals 2 over x cubed. Then that is 2 times x to the minus 3 power. And then du equals 2 times minus 3 x to the minus 4th power. So that's minus 6 over x to the 4th power. I forgot the x. Let me rewrite the given expression. I would write integration 3 times e to the 2 over x cubed times I'm separating the numerator and denominator to make things look better. So here we have 3 times integration e to the 2 over x cubed times 1 over x to the 4th power dx. From this relation, we want to get rid of minus 1 over 6 on the right side. So we would multiply by minus 1 over 6 on both sides. Then we have 1 over x to the 4th power dx on the right side. Let's change the variable. 3 times integration 2 over x cubed equals u. So it'll be e to the u, and 1 over x to the 4th power dx is minus 1 over 6 du. We have a number again, so we will write in front of integration. That's minus 3 over 6 integration e to the u du. That is minus 1 over 2 e to the u plus c. So that is minus 1 over 2 times e to the u is 2 over x cubed plus c. Do you have any question? Second problem is integration 2 over x minus 6 dx. We cannot separate the fraction because x minus 6 is in the denominator. And we don't have a formula, so we want to use substitution. Obviously, we have to put u equals x minus 6, and when you differentiate, you will get dx, so you will get this part. And we know that we can write 2 in front of integration, and we can rewrite it as 1 over x minus 6 dx. So I said we will put u equals x minus 6 and du will become dx, right? So it'll be 2 times integration 1 over x minus 6 is u, dx is du. So that is 2 times natural log of SL value of u plus c. And that is 2 times natural log of SL value of x minus 6 plus c. The next problem is integration 2x over x plus 8 dx. The previous problem and this problem looks somewhat similar, but those are different in nature. But that is somewhat similar to the problem we covered because the degree of the numerator and denominator are the same. And we cannot regard the numerator as the derivative of the denominator. But we notice that the denominator's degree is 1. So we will use that observation. Firstly, we will rewrite that one as integration 1 over x plus 8. We write 2 in front of integral times x dx. If we put u equals x plus 8, we have to do then du equals dx. So this part became 1 over u, and this part can be rewritten as du. And then we are converting the variable to u, and so we want to write x as u variable. So x equals u minus 8. Then it'll be 2 times integration 1 over u times the next one is u minus 8 du. In this way, we can expand this out and then we can solve the problem by applying the power rule. Let's expand that out. Then that is 2 times integration 1 minus 8 over u du. Then that is 2 times integration 1 du minus integration Let's write down 8 in front of integration and 1 over u du. So that is 2 times u minus 8 times natural log of absolute value of u plus c. So that is 2 times u is x plus 8 minus 8 times natural log of absolute value of u. U was x plus 8 plus c. I had to write down 16, right? Any question? The next problem is integration. Natural log of 2x over 9x dx. Again, we want to regard this as a product function, and we see what happens when we separate the numerator and denominator. We write natural log of 2x times 1 over 9x dx. And then this one is 1 over 9 times 1 over x. So I can write this number in front of integral. So 1 over 9 integration natural log of 2x times 1 over x dx. What we know from the derivative formula of natural log of x, if we differentiate natural log of x, then we have 1 over x. So what we have to do here is we will put 2x as u, because the formula is about natural log of x, not 2x. So u equals 2x, then du equals 2 times dx. In this case, we have 1 over x, so we have to put u equals natural log of 2x. Then du equals 1 over 2x times derivative of this, which is 2 dx. So that is 1 over x dx, right? So we can write it as 1 over 9 integration u times du. u du. So that is 1 over 9 u squared over 2 plus c. And then that is 1 over 18 u squared plus c. And then that is 1 over 18. U is natural log of 2x, but it must be u squared plus c. Any question? Yeah.
How did you derive ln?
How did I divide ln?
Where you said u was ln, how did you get
U equals ln 2x? So what I did was I regarded this one as a product function. And I observed that 1 over x is something to do with the derivative of natural log, right? So I decided to put u equals natural log. But u is a composite function. So I use the chain rule, 1 over input times derivative of the input, which is 2, right? Because inner function is 2x. And those will cancel each other, and we end up getting 1 over x dx. And then I'm not quite understanding the point of the question. So is that your question, or so your question was why 2 disappear? How did I divide this one? Yeah. The inner function was 2x. Yeah. Do you have any other question? I cannot see the people who are seated here. The next one is integration. 2 times log base 5 of x dx. From college algebra, what you already know is when we have log base a of b, we have a base change formula. So that can be rewritten as natural log of b over natural log of a. So we can rewrite it as integration 2 times natural log of x over natural log of 5 dx. These two are numbers, so we combine and write it in front of integration. So that is 2 over natural log of 5 integration natural log of x dx. So what is the formula for the integration of the natural log of x that is x times natural log of x minus x plus c. You have to remember, but later point when you learn about integration by parts, you would learn about how to derive this formula. The next question is the integration a to the minus 5x dx. The integration formula you have to use is integration a to the x dx is a to the x over natural log of a plus c. The power is x, but in the problem, the power is minus 5x, so we have to handle it. So u equals minus 5x, and then du equals minus 5 dx. So dx is minus 1 over 5 du. So we have integration minus a to the minus 5x dx. So we have integration a to the u, and dx is minus 1 over 5 du. So that is minus 1 over 5 integration a to the u du. So we could convert the given form into the formula form. So that's minus 1 over 5 a to the u over natural log of 8 plus c. So we change the variable. Original variable was x, so we write minus 1 over 5 a to the minus 5x over natural log of 8 plus c, because u was negative 5x. Any question? The next section is about integrals. Resulting in inverse trigonometric functions. The key formulas I'm writing down must be remembered clearly. Did everybody copy? We have integration 1 over x times square root of 4 x squared minus 4 dx. Here, when you look at the formula, what you see is there is no number here, right? This is just u squared. So what we want to do, so there are 2 ways to resolve this issue with number. We can convert this one as 2x squared, or we can just write the given form differently by taking out 4, because 4 is the common factor. So just you can take out this number to get rid of that inside of the under the square root sign. So 4 times x squared minus 1. And then what is that? That is square root of 4 times square root of x squared minus 1, which is 2 times square root of x squared minus 1. And what you know from the key formula, if the variable is multiplied to square root sign, then that's related to secant, right? So let me write it down again. 1 over integration 1 over u times square root of u squared minus a squared du equals 1 over a secant inverse of u over a plus c. This is the formula, and this is something we will just use to manipulate. We have integration 1 over, we have x, and this can be written as 2, thus this part can be written as 2 times square root of x squared minus 1. That's in the numerator, denominator. So we can take out 2 outside of the integration, but it should be in the denominator, right? And then that's square root of x squared minus 1 dx. So we relate this one with this part, and this one is just written in front of integral. Then we realize a is 1 because 1 is 1 squared. So we don't have to write 1 over 1. So we have secant inverse of u is x plus c. Did you understand? Any question? The next one is integration 1 over 3 plus 3x squared dx. There is no square root, so that's something to do with inverse tangent right here. Let me write it down again. Integration 1 over a squared plus u squared du is 1 over a tangent inverse of u over a plus c. So we have integration 1 over, we take out 3, then that'll be 3 times 1 plus x squared dx. Just in this case, we just get rid of this 3, so we took out 3. But fortunately, those numbers are the same. So it's quite simple integral. So we write 1/3 in front of integration. So 1/3, 1 over 1 plus x squared dx. So that is 1 over 3. And then again, a is 1 because 1 is 1 squared. Tangent inverse of u in this case is x plus c. The next question is integration. 1 over square root of 25 minus 25 x squared dx. This time, nothing is multiplied outside of the square root. So that's something to do with inverse sign. Let me write down the formula again. 1 over square root of a squared minus u squared dx equals sine inverse of u over a plus c. The formulas may be a little bit confusing, but you have to remember exactly as it is. There is no multiplication with 1 over a in front of sine. Just others have 1 over a multiplied to the inverse function, but for sine formula, there is no multiplication with 1 over a. Now, we notice that 25 are common factor, so we take that out. So integration 1 over square root of 25, 1 minus x squared dx. 1 over square root of 25 is 1 over 5. I will write it in front of integration. So 1 over 5 integration 1 over square root of 1 minus x squared dx. So what is that? That is 1 over 5 sine inverse of x plus c. Any question? The problems so far used the integral formula directly, but next sequence of the problems will be using the derivative formulas. So derivative of tangent, inverse tangent is 1 over 1 plus x squared. So again, this is a multiplication of two functions. And we can rewrite that as integration. Tangent inverse of x times 1 over 1 plus x squared dx. So we realize that this part is the derivative of this part. So if we put this part u, then this part will become du. So this one can be rewritten as integration u du, and then that is u squared over 2 plus c. So that is u. What is u? U is tangent inverse of x squared over 2 plus c. Any question? The next problem is integration. Sine inverse of 4x over square root of 1 minus 16x squared dx. We will do something similar. We regard this one as a product function of the multiplication between inverse sine and 1 over square root function. So 1 over square root of 1 minus 16 x squared dx. So when we differentiate inverse sine function, that is 1 over square root of 1 minus x squared. So if we write sine inverse of 4x as u, then that'll be something to do with this one. But maybe there is some redundant. Let's write u equals sine inverse of 4x. Then du equals 1 over square root of 1 minus 4x squared, because inner function is 4x, right? But inner function is not x, so this is a composite function. That means we have to multiply by the derivative of the inner function. So we have to multiply by 4 dx. So the difference between this one and this one is this number 4. So we rewrite 1 over square root of 1 minus 16x squared dx as 1 over 4 du. So this integration can be rewritten as integration u times 1 over 4 du. So that is 1 over 4 times u squared over 2 plus c. So what is that? That is 1 over 8 u squared plus c. That is 1 over 8 u is sine inverse of 4x squared plus c. Do you have any question? The next one is integration. Secant inverse of 3x over x square root of 9x squared minus 1 dx. The derivative of secant inverse of x is 1 over x squared of x squared minus 1. So when we write this given form as secant inverse of 3x times 1 over x square root of 9x squared minus 1 dx. It is the derivative of the first part up to constant, right? So I will put this one as u, and we will differentiate and see how we can compare that with this one. U equals secant inverse of 3x, and then du equals 1 over 3x square root of 3x squared minus 1 times derivative of the inner part is 3 dx. So these two will cancel each other. And then we have du equals 1 over square root of 9x squared minus 1 dx. Yeah, I dropped x here. So denominator contains x. So we know just everything cancel each other, and then we have du here. Any question? No question? Okay, so when we rewrite the integration with the u variable, we have integration u du, and that is u squared over 2 plus c. So u is secant inverse of 3x squared over 2 plus c. Do you have any question? Did you learn about area between curves? Yeah, I think that's also a review. And then the new material. Let's start with integration. We have a function like this. Let's suppose that the function is positive and continuous. Then integration a to b f of x dx that could be regarded as area under the curve. You know how that was developed? Just we thought about the rectangle and we added the rectangle and we make the rectangle thinner and thinner. And then that approaches area under the curve. The reason I'm talking about that again is we want to extend the notion. So to extend the area under the curve, the notion of area under the curve to area between curve, we will regard this x-axis as a constant function. So we can say that is area between y equals f of x and y equals 0, so which is x-axis. We want to extend this notion to area between two curves. Let's say this one is y equals g of x, and this one is y equals f of x. And we want to think about the area between two curves on the interval a and b. Instead of drawing the rectangle by using x-axis, we will draw the rectangle by using these two functions. And this one is delta x, and this random midpoint is xi star. Then the length of this rectangle, length of this dotted line is defined by the function value of f and g. So it is f of x I squared, ai star minus g of x I star. So we can say that A equals limit n goes to infinity, summation I equals 1 to n, f of xi star minus g of xi star times delta x. What is happening here is f of xi minus g of xi is this height of this rectangle. And this one is width. So and then this summation notation is just saying that we are breaking this interval into finite number of interval. And so that means this n is the number of this n is number of rectangles. So of course, when we multiply those two, we will have the area of ith rectangle. What is the meaning of this limit? N goes to infinity. That means rectangles become thinner and thinner, so become slim and almost like a stick, just the vertical line. So that becomes the area between two curves. And when that is the situation, this limit summation was denoted as stretched S, so integral sign. And we denoted the lower and upper bound, A to B, and f of x minus g of x, and delta x, when that is extremely thin, it is denoted as dx. So that is the area between curves if f of x greater than g of x for x is in A to B. We want to find the area of a region between two functions. R is the region bounded above by f of x equals minus 5x over 4 plus 5, and below by g of x equals minus 2x plus 4 over the closed interval minus 1 to 5. So in the problem, it says R is the region bounded above by F and bounded below by G over minus 1 to 5. So we have two possibilities. Something like this. And minus 1 is here. And y equals f of x. This one is y equals f of x. This one is y equals g of x. And this is 5. Then what you realize is we can just integrate from minus 1 to 5 because f is always larger than g of x, right? But there is another possibility. It becomes like this. This one must be y equals f of, based on the problem, this one is y equals f of x, this one is y equals g of x. And this is 5. Then f of x is larger than g of x in this region from somewhere between minus 1 to 5, right? So what I'm trying to say is we cannot just write integration minus 1 to 5 f minus g dx. We have to make sure that this intersection point is not located between minus 1 to 5. To do that, we have to figure out the intersection point first. The one equation is minus 5x over 4 plus 5. That equals minus 2x plus 4. So we just multiply by 4 on both sides, then that is minus 5x plus 20 equals minus 8x plus 16. And we add 8x on both sides and subtract 20 on both sides. Then that is 3x equals minus 4. So x equals minus 4 over 3. And this one is not in minus 1 to 5. So that is number 1. So in this region, f is always larger than g of x. So integration minus 1 to 5 f of x minus g of x dx is integration between minus 1 to 5 minus 5x over 4 plus 5, that is f of x, and g of x is minus 2x plus 4 dx. This one is 8 over 4x. Let's just combine the like term together. Minus 1 to 5 minus 5x over 4 minus will make plus 8 over 4x plus 5 minus 4 dx. So that is from minus 1 to 5. Minus 5 plus 8 is 3 over 4x plus 1 dx. So that is 3 over 4 times x squared over 2 plus x from minus 1 to 5. So that equals a 3 over 8, 5 squared minus 1 squared plus 5 minus 1. That is 3 over 8. What is this? This one is 25 minus 1. And this one is 6. So 24 plus 6 is 30. So you can just calculate it. 3 over 4 times 15, which is 45 over 4. Do you have any question? Do you have anything to point out? Yeah, so I made one mistake here. So I wrote here, and I wrote large bracket here. And I made a mistake by making redundant here, right? So I had to calculate this part and this part separately, but because of this redundant, I just combined this one first and then multiply by the fraction and ended up getting a wrong answer. Oh. Do you know what I say? Yeah. So let me fix it. So that is 3/8 times 24 plus 6. So 3 times 3 plus 6 is 15. Any question? Oh, this is 11:06. I think it is better to finish here, and I will send out an announcement about next week's quiz next week, Wednesday, and I will give you further instruction. Definitely, I will write it after I make a quiz. Yeah. Yeah. There are a lot of formulas we reviewed together. So definitely a significant part of the quiz next week will test you whether you actually remember all the formulas correctly. Do you have any questions? If you couldn't understand any part, then you can come out and clarify before you leave here.